Hello, everybody. You hear me? Yes, you do. Excellent. So, this is Jerome Etienne, me. This was Jerome Etienne. This is the blue. This is where my slide will appear shortly. Here we go. There. So, hello everybody. I will speak to you today about augmented reality, and in particular, web in augmented reality. I expect to show you, to convince you as much as I can, about the web being a great platform for augmented reality. My name is Jerome Etienne. Alexandra Etienne is usually doing this talk with me, but she is unfortunately not able to travel today. So I will do this talk alone for once. So first, what is augmented reality? A picture is better than words, so let's see how Hollywood movies see augmented reality with some example in Blade Runner. Here, I don't know if I have some laser. Okay, probably not a good idea. I don't have any laser pointer, so I will use my mouse. Here you see big augmented reality characters on the actual, I think it's Ryan Gosling looking at the augmented reality. You got a real character looking at an augmented reality character. This is one possible use of augmented reality. Another one is you walk in the street, and as you can imagine, here you have a dancer with some marking, and all that is augmented reality. So this is one way Hollywood sees augmented reality. For them, augmented reality is like special effect for the real world. You walk around, and what you see through your eyes is like what's going outside. I don't know, Hollywood editing movies. You augment your reality by adding information into it. To give you more of an idea of that, we're going to look at Luke W. IDs. This guy is a well-known, let's say, generator of ID about what augmented reality can be. He's good at user experiences. So this is one user experience that we could have once augmented reality is everywhere in the future. So you are in a shop, you have a lot of product in the shelf, and you want to know the review, what your friends are thinking about this product or this product or this product. Maybe the ranking on Amazon is not as good as you would expect, or it's better than you would expect. You use those additional information in order to make your choice. This is one possible use of augmented reality. This one is very futuristic. Just imagine you are walking through the woods and you see plants all over the world, and you want to identify the plants. For example, in this case, this is a poison oak, meaning that's poisonous, so it's probably not a good idea to hit it. This is very futuristic. Technology is not yet there. Another one, much simpler to implement, is you're at home and you want to wash clothes. But they always have these kind of labels that you can never read, or at least in my case, I can never read or translate, or maybe this is in some Asian characters or some stuff. Maybe the logo I have never seen. The phone will scan the label and tell you exactly what to do with it in a language that you understand yourself. All that, this is a dream. This is how Hollywood see it. This is how visionary people see it. This is nice, because this way we have a good idea of what the reality will be with augmented reality. So let's see how it is today. First, let me tell you about how easy it is. I would like to keep you at ease. Just because you see that in movie, just because you see very, let's say, impressive video on the web, that doesn't mean that it is hard for you to produce augmented reality. Many people think augmented reality is complex because they think, all right, there is a lot of mathematics, a lot of 3D, I will never have the time to do that. Well, they are right, there is a lot of mathematics, a lot of 3D, but hopefully we will make it much easier for usual developers to access all this technology. This way usual developers do not need to fix all of this. So AR is easier than you think, at least I think. For me, it's important to always deliver simplicity. There is Albert Einstein who said, do everything as simple as possible, but no simpler. This is our camera principle, and this is something that I apply everywhere I go. So when I did augmented reality, I applied the camera as well. So let me show you how to do augmented reality in only 10 lines of HTML. Here you got 10 lines of HTML. This is very simple. This kind of code is very familiar to any web developer. This is very important because we want augmented reality to be easy to create even by web developer without the need to be, I don't know, an expert in 3D or an expert in computer vision. We want the application to be, AR application to be developed by everybody. So what this application is doing is something very simple. It takes a marker and put a cube into it. So it's basically the image as an output. If you can put that directly inside CodePen. So this is Alexandra just there, smiling as always. Here you have the code on the right and the marker with the cube. So this is as simple as that. The fact that it's working CodePen shows that it is very easy to deploy and install. Let's break it down. I would like to not actually teach you how to do augmented reality. I have tutorials, I have documentation, I have codes everywhere post. So this is not the place to do that. But I would like to give you a glimpse of how easy it is to do. So this is the 10 line. Let's go through the 10 line one by one. First, the first 3 lines. Simple. You have here 3 scripts, basic script. You include your dependency like you do in many, many web pages. If you are a web developer, you're completely familiar with that. Here you include FRame. That's a framework in order to do 3D. And after that, you include ARGS. That's a framework in order to do augmented reality in JavaScript. 3 lines, simple, cut, paste. Then you define the body. You are, once again, very familiar, business as usual. You have a HTML body tag in every pages. Here we go a bit different, is because FRame is defining some custom entity, you will define a scene. So what is a scene here? It's a bit different than usual web page. A scene is 3D is basically, you describe the 3D. This is, in this case, a simple box. This way I keep the example simple. But you can have a box with button and a dragon spitting fire or whatever. This is any 3D, we call that a 3D scene. In our case, as I said, in order to keep the example simple to understand, I just defined a very simple scene, a single cube. Here, I modified a few attributes. So, a box, obviously this is a box. The position, X, Y, Z. I put the Y just a little bit above, this way the cube will be above the marker. On the material, I change the opacity, this way it will be a bit transparent. This is as simple. Obviously, the documentation shows all the possible attributes that you can change and what do they do and so on. It is just to give you a glimpse of the idea. And the very last line that you need to add is just a camera. This is always the same line. You say, I add this camera there and make the camera move in 3D as if it was my phone. So you move around your phone and it acts as a camera within your 3D. And this is it. You got the whole things, just there, you did augmented reality with a marker, and you have a simple cube. You could include models that you find on internet and so on. 3GS and FRAME are able to support many, many, many models and many formats of model, so you will not be limited by that. So augmented reality is easy with ARGS. Let's focus on how ARGS is born, how we started WebAR. I started to do WebAR a long time ago, well, a long time in a computer view, 5 years ago, and I was already fooling with WebAR at the time. Here's a video 5 years ago. It's always like to make a fool of myself, so this day I choose to appear as a clown once again. So the nose, obviously, is augmented reality, the red nose on the pointy hat. I have a huge marker. Well, that seems a bit silly and strange, but at the time it was quite an achievement. Even reading the webcam was an achievement. So to read the webcam, to put 3D, and to do augmented reality in the process, it was rather good. Completely not usable by the masses, though. It was a prototype in a corner. So how it all started? As we have seen, I have done some things in 5 years ago, which is long from a computer time scale. In 2015, I got hired by DACRI to lead their WebAR team. And so DACRI is an augmented reality company who do a device specific to industry. So you have an helmet, protection helmet, and you see through the visor the real world. Obviously, we put augmented reality because we have a computer inside it. Unfortunately, DACRI did a massive downsize at the beginning of the year. They let go 150 people. Me and Alexandra were in part of that. So we could have, I don't know, reacted poorly because suddenly, out of the blue, without any warning, we both got laid off, no more salary at the end of the month, from X to total 0. But we choose to see it differently. We choose to see it in such a way it was positive. So the positive side in all of that, when you got laid off, my bad, and when you got laid off, is you have a lot of free time. This is definitely a good part. And what can we do with this free time? The way we choose to use our time was to focus on delivering the dream that we wanted to have. We have a view about what WebAR should be. This way we can leverage all the knowledge we already had, all the experience we already had. Now, as we have the time, let's build this and deliver that to the people. This way we can build a community around the WebAR project. So we were focusing on ARGS. That's the name of this project. We started by working on efficient augmented reality on the web. I will come back on that. At the beginning, it was only marker-based, so you have a marker around. So it's not exactly not the best, but the most modern one. But it is very fast, and this is key. That means that work on any phone, even 2-year-old phone. This is really important. So at the beginning, we identified we wanted to focus completely on the performance of it. When I started, I took and I did a naive implementation. Out of the blue, I got 4 FPS, 4 frames per second. So basically, you move and you got an update of the 3D 4 times per second. This is nice from a technological point of view, but not really useful. You show that to your friend, if he's a developer too, he may say, oh wow, that's nice, because he likes you and all, but all right. But all in all, you show that to anybody, normal user, he will not say that because 4 FPS is not fast enough to be useful. And so I had to optimize it and optimize it and optimize it for a long time. And after that, it was 60 FPS on 2-year-old phone. And this makes a whole world of difference. It went from a technical toy that you can show technical friends or technical conference to an actual product that you can use, because at 60 FPS, 60 frames per second, the 3D is moving smoothly and nicely, and everybody is happy and they don't care about the technology. You show that to a user, it makes it usable. The performance boost is make it usable. So I was quite proud of that. Let's look at this video. So this is a video. So you see the phone with the 3D on top of the marker. It runs at 60 FPS, even on 2-year-old phone. Full open source, based on web standard. We will come back on that. Free of charge, so you can use it without paying me. Don't forget to have fun when you do augmented reality. It's a key point. All right. So this video that we have seen here is the video we used in order to release ARGS on Twitter. So let's go on Twitter role in the origin of WebAR ARGS. At the beginning, I was a normal Twitter user. Maybe I still am, but when I started ARGS, I talked to the community through Twitter. I kept talking and talking and talking. It changed a lot my experience on Twitter. It multiplied my number of views by 10. And so at the beginning, you say, wow, that's an ego boost. You feel good. You feel like a star. But in fact, that's much more useful than just an ego boost. At some point, I even had 500,000 views per month. So for me, at least, this is huge. This is really important. I realized that this was significantly more than an ego boost. That was an actual contact with the community. That was a way to build this community. So because I do open source and I was doing that full time, remember I got laid off, so I spent 10 hours a day at home coding this. Because I am alone, when I have a question, I need to fix it alone. So it's not easy. There's many things that I don't know. I could use Twitter, ask those questions, and people within the community will answer me. So suddenly I realized this is an actual tool, something very useful, not just, wow, I'm a star, or whatever. So 500,000 views is actually useful. This gives you visibility. And even now, this is the best way to contact me. So Twitter was nice, but it was a public vision of the project. This is how the community saw me. That's, most of them knew me only through Twitter. But my real life was a lot more like being a duck. It seems like a weird sentence. I will explain it. So this image explains it completely. When you see a duck in your river or some kind, the surface is very calm, composed, unruffled, peaceful, effortless. Below the water, this is where it all happened, but nobody sees that. You paddle like hell inside, and this is how you get forward. And this is important. The hard part is not the one which is public, just because. So, under the hood, it was a lot of responsibility. Everybody was looking at me. Everybody was looking for feature. If I had a bug, be sure they noticed. And they say, please fix, please fix. So a lot of work. Somehow it feels good because you feel like a star, but in practice, it's really a lot of work. So underwater, you have to do this complex software. Let's not forget this is augmented reality. So augmented reality on the phone in JavaScript as well. So augmented reality means computer vision. Computer vision, those are complex algorithms, lots of mathematics, lot of very big flow of information to process. You have to do all that on a phone, not exactly the most powerful device on earth. Obviously, I would prefer to have, I don't know, NVIDIA 1080 with a big desktop, 2K a desktop, something like that. It will make my life easier. But I need to work on a phone. I need to work as well on JavaScript, not the fastest platform ever. All of that, complex, slow platform. I need to fix bugs, improve stability. Usual software engineering when you think about it. But that's a long, ungrateful work, but it is needed. Because all this community will never happen if ARJS doesn't work for real. So when I take my phone, it has to work. So being a doc was great in a way. At the beginning, I was alone, only two hands. This is quite important because you need to do your own code with the complexity of the code that we evoked, the design, the architecture, everything. I was working 10 hours a day, unemployed, so not making a penny. But that was great. And this stuff stopped too. No, it does work again. So let's go deeply, more deeply at least, about what is ARJS as a project. First, the mission. The mission of ARJS is simple. Bring AR, augmented reality, to the web. It's a bit broad, but it's a mission. That's like the principle of a mission in a way. ARJS has four key components, four axes to define it. First, that's very fast. It has to run fast in order to be immersive. If you move around on your augmented reality sketchy, suddenly it's not immersive. Augmented reality has to be immersive. This is web-based, so it runs within the browser. It's open source, important, so you don't have to pay me. You can contribute. Please contribute if you can. I enjoy any contribution. And it relies on standard. Let's look about all those four components on how they can define the project. So ARJS is very fast. That means it runs efficiently on mobile phone. As I said, mobile phone in JavaScript to run efficiently is not easy. So at the beginning, I was 4 FPS on iron phone. After a long, mostly long night of optimization, it was 60 FPS on a 2-year-old phone. 2-year-old phone is really prehistoric in a time scale. And so 60 FPS there was clearly good. ARJS is web-based. What does this mean? That means that it is coded fully in JavaScript. That means that it runs in a pure web browser. It is based on 3GS on JS AR Toolkit. So 3GS is the way to do 3D in the web. Basically, that's a library that makes WebGL easy to do. And JS AR Toolkit is AR Toolkit compiled to JavaScript with OM scripter. You can, after that, ask me a question if you want a lot of technical detail about all that. What is interesting here about the web-based is there is no installation required. You don't need to install an application on your phone. This is very key because nobody likes to install an application on their phone. First, you need to download the application. Second, you need to authorize, blah, 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 blah. It's always scary. And after that, you use space on your phone. So people don't like it. One good thing about web-based is you don't need all that. There is no special permission. There is no special download. There is no space used within your phone. ARJS is supported by every operating system. Well, I guess most of the operating system on mobile phone. It is supported by Android. It is supported by iOS. It is supported by Windows Phone. So all in all, most of you, surely most of you, have a phone which is supported by ARJS. How we achieve such level of support is because we rely on standard. Here, ARGS assumes that the web browser supports WebGL for 3D and WebRTC for camera. And if the browser supports both, you are in business. ARGS will work. This is good because this works on your mobile phone, this works on desktop as well, all desktop, all operating system, all browser on the desktop. So Safari, Chrome, Firefox, in all platforms, you can do ARGS there if you want to. There is no specific API to support, no specific application to install. Just a web browser is enough. So now you have a good idea of how it all got started. What happened after that? So we started the history into February of this year. In June of this year, something big happened when you do augmented reality. It's the announcement of ARKit. So Apple announced ARKit. It all started at the beginning of the year by vague rumor from Tim Cook, CEO of Apple. He just arrived and made very vague, non-committal kind of declaration, like AR is the future, or yeah, AR will change how we interact with the world, without saying anything about what Apple will deliver or any date or any product. So we all had the impression that Apple will release something shortly without knowing anything about what they're gonna release. Obviously, Apple did a lot of acquisition on the AR field. They acquired Meta.io and such, spent a lot of money in those acquisitions. So, in ARKit, what was they released in June? What did they say during the release? First, this is markerless tracking, meaning that you don't need any marker. You are in the street, you take your phone, you point it anywhere, and suddenly you can have augmented reality just there. You can be in the street, you can be in a conference, you can be in your bedroom, you can be in your office, whatever. There is no setup, and this is a key part. Additionally, they have a good understanding of the world around you. Here, this is a technical term that we call heat testing. That's a strange term. So basically, that will mean that the phone is able to detect plant within your world, is able to detect the ground, is able to detect the table, is able to detect your desk, whatever. The main advantage of that is when you put augmented reality somewhere, you can put it on your desk. You can, I don't know, suppose you have a virtual pet in augmented reality, and every time you sit at your desk, you want to see your pet. So you click on the desk and you see your pet close to your keyboard or something like that. Additionally, this was available on monocular camera. So I will come back on monocular camera because this is important. But all in all, ARKit was really, really big. It was a bomb for the augmented reality world. This was a real thing. At the time, so in June of this year, it has been a big year for augmented reality. At the June of this year, Apple was the best. Not because of the tracking accuracy. The tracking accuracy was okay, but for example, Microsoft HoloLens has a better tracking. Google Tango has a better tracking as well. But they both require a specific device. HoloLens costs $3,000. Not many people can afford to have a device of $3,000. Tango requires a specific device. This is a phone, normal phone, but it has some strange camera, not unusual camera in the back. Some depth camera like you have in Kinect, for example, on some wide angle camera, not usual cameras that you have on your phone. Because both of them either cost a lot of money or require a specific device, this makes the adoption of augmented reality much harder to do. Because most people, how many people among you has an HoloLens? one, which is a talker. So I'm guessing you are doing augmented reality in a way. So all in all, that's $3,000, and nobody is spending that except, well, a few people, but very rare. Apple was very different because they say, on the next iPhone, everybody will get augmented reality. This is very significant when it is about deploying augmented reality to the mass. So this move of ARKit was key for user adoption. AR will be included in your phone, in your pocket. You already have a phone, so you will get AR. This was a promise. AR was by default. There is no need for anybody else. So all that happened due to this weird word, monocular camera. Let's talk more about this monocular camera. Monocular camera means simply a camera with a single lens, like most of you have in your phone. In fact, all of you have in your phone. A webcam in a desktop on a laptop is a monocular camera. It's a normal camera on which you do a webcam. Because this is available everywhere, that means you don't need a specific device. Any iPhone will be able to do it. Even old iPhone, you don't need to have a specific iPhone with specific camera. And this is absolutely key, to have AR by default. So everybody was rightfully impressed by the move of ARKit by Apple. Unfortunately, to have Apple as a leader was kind of scary. I don't want to start any war between pro-Apple, pro-Google, pro-blah, blah, blah. It's just Apple is like to keep a very tight control over what they do. They don't share much. They promote closed solution. And they like their store a lot. They are doing 30% on, I believe, on every sale. So they like it a lot. So all in all, ARKit has its advantage on this default, but ARKit demos were everywhere on Twitter. It was all made by Unity, so this is an important point. To have Apple as a leader of AR means likely no ARKit on the web. And this is key in my case because I was very sad, right? When you see demo working only on iOS and only if they are made on Unity, and you are promoting the web on the openness, on availability to all, you're very sad. That doesn't match my personal view. So Apple was a leader, but pushing for the App Store. Native have a lot less advantage at the web, at least in my perception, so it was really not a good time for web AR. Let's look more about what is web AR versus native AR. First, from a developer point of view. When you are doing the web, so web AR, you write your application once and it runs everywhere. This is the concept. When you do a web page, you don't write it for Mac, you don't write it for Windows, you don't write it for Android. You write a web page according to the web standard. You use usual web technology. You don't need to learn iOS-specific language or iOS-specific API or Android-specific language or Android-specific API, and so on. So first, single API, single language, you write it once, it's run everywhere. This is the web. Additionally, there's a lot more web developers than there is mobile developers in the world. So it's much easier for you to find developers, it's much easier for you to build a team around that. Now, what is the difference between web AR and native AR from a user point of view? So the user doesn't care about the technology, but the user experience the difference of those technology. First, when you do web AR, you are not installing application. And everything shows that nobody likes to install application within their phone. This is very big because it takes, as I said, it takes space on the phone. It asks you for permission. You may need to pay, and so on. So on the price to install an application, most of the time, after 30 days, 90% of the application got uninstalled. So user doesn't like application to install. Yet, all in all, obviously, as we have seen, ARKit has its default, especially when you like the web AR kind of vision. But it was great, because this was by far the biggest move ever toward deploying AR. Suddenly, Apple promised to deploy AR to everybody with an iPhone. This is 12% of the world market. This is 40% in the USA. So it's definitely big, right? It was very good for the user. Sorry, word that's missing. So AR from a user deployment, a mass deployment, it was becoming real. Fortunately, for me at least, for web AR, Google released AR Core in August. We will say why I say fortunately. So in AR Core, in August 2017, so like 3 months ago, they released AR Core. AR Core, from a feature point of view, is extremely similar to ARKit. That's completely the same. Basically, it will work on monocular camera, so most Android device will be able to run it. What else? He's doing it testing the same way, so he's able to detect the ground, he's able to detect the table. You can put your AR on your table, on your bed, on your desk, whatever. And before, Google had a very good technology which was called Tango Project, but all those Tango Project devices, first you needed a specific devices, and those devices were more expensive or too big. And basically, okay, let me ask again, who has a Tango device? Not even the previous one. Okay, nobody in the room has a Tango device. And why? Because first they cost money, and there is only 2 devices available in the world right now, just to give you an idea. Obviously, I have one because I'm a professional of the field, but nobody gets a Tango device out of the blue. So the coming of AR Core changed everything again. Google on augmented reality meant a lot when you are like me promoting the web. First things, obviously, is iOS is 12% of the world market, so it's rather good, but Android is 88% of the world market. So suddenly we had Google and Apple, both major vendors. Together they provide the whole software stack in mobile, and they both provide good AR. So it was really good for me. And additionally, Apple was no longer a monopoly on augmented reality. That means that Google and Apple will fight together for the benefit of the user. When you are doing economy, diversity and competition are healthy from a user point of view, or for the ecosystem as a whole. So the fact that Apple released ARKit pushed Google to release AR Core, and now they're fighting together, which is very good for us. Google exposing AR on the web. Google, by, let's say, tradition, that's like their trademark, they push web technology. This is all they do. Apple push its store, and Google push the web technology. Very short caricature. So what Google did is they took Chrome, they did a modification of it, and published that as 2 applications. On iOS, they published something called Web AR on ARKit. This is the actual name of the application. On Android, they publish Web AR on AR Core. Both are Chrome program modified in order to read AR core and expose it to the web. So it was a dream for me, because suddenly those two applications were exposing all the AR core tracking to JavaScript, so you can easily build augmented reality application with AR core tracking when it was available. You could easily build ARKit application in JavaScript when it was available. All that with a single API to do both. By the way, Google is most likely to include those modifications in stable Chrome in time. I'm not sure exactly when. So let's look about those two technologies by those two major actors, ARKit versus AR core. ARKit is done by Apple, AR core is done by Google. ARKit represents 12% of the world, AR core represents 88% of the world. And obviously one is available on Android and the other is available on iOS. Both are available within a web browser. So even today, you can build an ARKit application in JavaScript without issue. And this is absolutely great. The similarity, ARKit and AR core are very, very similar from a technology point of view. They provide something we call inside-out tracking or markerless tracking. They provide heat testing, so you can put your AR on the ground, you can put your AR on the ceiling, whatever. Additionally, they do ambient light testing. So when you do 3D that you put on the ground, you want 3D to be lit as normal object. Let me show you this guy. So here you see the lion is well lit. Suddenly the human shut down the light. So the light on the avatar is changing as well. This is natural and this is the way we like it. So when AR core on ARKit estimate ambient light, you want the light of your 3D to be high if you are yourself in a broad daylight. If you are in a dark room or during the night, you want the light of your 3D to be low. It is that simple. Let's look at some example of what you can do with AR core on ARKit. Check it, okay. So this is a virtual pet. It's a very classical application when you do augmented reality. You have a very cute dog. You are in the park and you are playing fetch. You throw the stick. He's running. He's coming back. Cute little puppy. He's breaking back. Isn't he cute? Okay. Usual applications. Here's another one, more creative, where you can, let's say, mold or sculpt 3D in augmented reality. This is an iPad. You have a, let's say, mold of clay floating around, and you can build some kind of avatar. I'll let you watch. You can change the color, colorize your place, all that through your iPad. Okay, you put some eyes, some paper, suddenly it looks like something. There we go. So this is sculpting in augmented reality. Okay, this one is a lot more classical, and this is a portal between virtual reality and the real world. So, let me explain what's happened. Stop. Here we go. Computer doesn't like me. Okay, here you are in the street. I don't know exactly. It looks like London or something similar. And you have a portal that you see in front of you. Through this portal, you see a virtual world. Okay, click. So you walk through the portal, and suddenly you are somewhere Oh yeah, this is in San Francisco. We will see the bridge soon. You see the sea, see the bridge of San Francisco just there. And you return and you see the portal. From the portal, you go through again and you come back to reality. This is a good way to, I call that the door between augmented reality or virtual reality. Is suddenly you are from the real, you walk through the portal, you go into virtual, you turn back, and you can come back from the real. You can do that in ARGS too. I will show that in a minute. This one is interesting due to the quality of the visual. So those big objects, or those drones, are completely virtual. But the fact that they are so realistic from a rendering point of view, you arrive, and this looks rather cool. You may always believe that it is there. When you get close, you see the details are nice. Imagine there is some sound, maybe you can talk to that, maybe talk to you. The fact that it is very realistic changes a lot of things in the immersive side. This one has been done in Finland. Okay. All right, so let's come back to ARGS. What we have seen is, so all the demo we just saw about ARKit on ARCore, you can do the same stuff in JavaScript on WebAR. Here you have a demo of Tango running in my apartment with ARGS. This is my cat, even in the back, if you like cats. So what ARGS is now? ARGS has evolved quite a bit since the beginning. First, we made it available on A-Frame. A-Frame means this is a framework to do 3D for web developer. Very similar. This is the example that you have seen at the beginning. Is make 3D very simple for beginners, which is perfect. Additionally, ARGS is available on Babylon now. Before it was available on A-Frame and 3GS. Babylon is a 3GS framework, a WebGL framework done by Microsoft. I ported ARGS to it. Additionally, ARGS support Tango. Tango means they have excellent tracking, they have excellent testing, so it is supported by ARGS. But most of all, ARKit on ARCore is definitely supported by ARGS. That means a lot, in fact. So this is my room, or not my room, my kitchen, or me playing in the kitchen. What does this mean is ARGS support all kind of tracking. If you have ARCore on your phone, ARGS will use ARCore. If you have ARKit on your phone, ARGS will use ARKit. And if you have a normal phone without ARKit or ARCore, ARGS will use pure web tracking with markers. All that with a single source. This is very important for application developers. Why? Because this way, they write a single application, and it will work on all the possible tracking and choose the best. So ARGS provides the best tracking available on your device, no matter what your device is. This means one source for all platforms. You don't have to write one iOS application. You don't need to write one Android application on another application for people without ARCore and ARKit. This is where WebAR is so powerful. This is where it shows. So you write your ARGS application once, and it runs everywhere. Let's look at some demo. You will know a lot about my apartment soon. If I have internet. Okay. So this is my apartment. I live in Dublin, and this is Hatsune Miku. This is an anime which is like the égérie of augmented reality. She's dancing in my apartment. You can move around. So she's singing. We are not hearing there. He's dancing, you can look at my cat, not impressed, definitely not. And so on. All that open source, by the way. So this is Hatsune Miku. So this one, the previous one was on Tango. This one is on AirCore. It's a lot more techy, but you get the stuff. So here the 3D, there's no model, that's just a debug with a cube running. But you can see he's floating around in my room, not moving, well, being stable. So augmented reality with AirCore works. So what can you do with AirJS? Here you can see shadows, for example. I like to synchronize the lighting of the real world versus the virtual world. Here, these little M&Ms is actually real, so the shadow is real. But this torus knot is not real. But still, the shadow sync, so it's better for your mind, and it's more immersive this way. This one is interesting. I use refraction to simulate glass. Let me show you this one. Still in my apartment. So you have this big torus floating around. Obviously, it's virtual, right? But it appears as glass. So I see through this virtual object, and it reflects the real world. So when you move around, you see there's some deformation. You can even enter inside the torus. And my wife appearing somewhere soon. Here we go. So she's seeing through. All those tricks like using shadows or using glass is really important to trick the mind and make you think those objects are real. Another aspect is to make it appear as magical. Here, this is an effect called hole in the wall. So I have a marker, and I make it appear as it is a hole inside my table. But obviously there is not. This gives kind of a magical effect, and that people like. So after that, I'm not a modeler, so I do wear table like that. This is the same effect as the portal, by the way. Okay, the portal AirJS version. So here you are on my table, you have a portal. All that is a bit small scale, but this is due to the demo. We go through the portal, and suddenly we are in the virtual world, and we look back through the portal, you see the real. Obviously, when you come back through the portal again, you will go into the real, and you can still see the virtual through the portal. There's a movie like that of, I don't remember. Okay, there's a movie with portal everywhere. I don't remember the stuff. So with that, you can build web AR, you can build various applications. You can do AR gaming. Here you can see how to use marker with various to do gaming. Let me see if I can show you. How much time do I got? Nobody is moving in the regie, okay. Okay, so here you have an augmented virtuality game. Here you move your markers and you see how the 3D adapt. It's like an input. In fact, the markers start to be an input, and this is good for augmenting the table. Here you play around with the table, and you can play. So you move the marker, suddenly you intercept the ray, and oops, you control everything like that. All those games are done on PS Vita, but you can do exactly the same with WebAR on AirJS. This one is a track, so there's some car moving around. If you move dynamically, the markers, the track will move dynamically. Let me see if I can find it. Okay, let's look at some example. So what you see around is a PS Vita. Here you see some sport, augmenting the table as well. So it's got some. Here you got the track. You move the track dynamically. It moved, so the car follow. It's very simple. Here you can edit like a virtual world with, I don't know, kind of tiger. Once again, a pet. And you control the pet by moving the markers. You could easily build that if you wanted to. Area 51 version. Yeah, you can. So this is the inside of the alien. And the alien is still alive. Yes, special area 51. More seriously, you can use AR in education as well, which is quite interesting because when you are doing augmented reality in education, one thing is, for example, suppose you are learning history and you want to learn about some battle with Napoleon or blah, 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 or whatever history you want to teach. It's much better when you see a live story than just some text, static on your stuff. So, for example, this is 2 school books. One of them you learn about the Earth. So they show you the Earth, the various layers through the Earth. They teach you anatomy as well. AR works very well with educations. You can use it in multiple fields. So you can use it in the industry. You can use it in e-commerce. You can use it in medical training. All the AR at the moment are very creative. So your imagination is the limit. We are very excited to see what people will do with WebAR. I hope you are too. Do you have any question? Yeah? No question, nobody? Yes, I got one.
What about interactions with that AR object you have?
There is several possible interactions. The easiest one is simple. You have a wonderful touchscreen, so you can swipe, you can click. There's a big microphone here, and so you can actually talk to it. And there is an API which understands what you do. One thing that I did at some point is you talk and you say, call John, and he goes through your contact, he finds who you mean by John, and actually do a video call with you. All that in augmented reality. You can, for example, we were talking about virtual pet. I don't know, maybe just hello, doggy, go fetch. I don't know. Let's hope you are better than me at that. But you can talk, and the API will understand. Even it can even talk to you, talk back to you if you want to. So there is a screen, there is the voice, there is markers as well if you want to. Another interaction is the fact to be close. So suppose there is a marker here. I go on the fact I am close, you will activate this avatar on when I get close, suddenly it will act differently. If I am here, it will look at me. If I move around, it may follow me as well. I did that at some point. So you have a pet, and wherever you go, it follows you. So when you look back, it's there. It can never do noise because the sound on the web, you have something called web audio, which is directional sound. That means that I can hear the sound from behind, above, below, and so on. So this is the kind of interaction that you can do. Another question? Go ahead.